Hello, our project is SDSU parking structure, photovoltaic solar carport structure. Merge Consultant Engineering is a group that consists of 6 members specializing in structural and construction engineering that will help to deliver the best possible design for the project with the best cost. This is the design team starting from the left: Nasser Al-Faraj, Ahmed Barkadar, myself Musab Al-Nizi, project manager, Jasim Murad, Mohammed Al-Abbad, Ali Al-Ajmi. San Diego State University, with almost 32,000 students that go to campus, is looking to be a leader in renewable energy. The university is looking to install a steel carport on the rooftop of parking structure 4. San Diego State University is seeking assistance to determine the best and most cost-effective solution. Parking structure 4 is located west of campus, north to Vijas Arena. The parking structure is an 8-level parking structure. The structure is post-tensioned, long-span structure with 24-foot wide bays, 6-inch slabs and 36-inch beams, approximately 22,200 cubic yards of concrete. Calculations will be made through SAP 2000 app. Findings: it has a high strength to weight ratio, which means it has high strength per unit mass. Can be easily fabricated and produced massively. Steel is relatively cheap compared to other building materials. The safety of existing structure of reinforced concrete building will depend on initial structural configuration of the total building and can be checked by field test to check strength of concrete elements.
I'm Mohammed Al-Abbad and I'll be talking about the steel structure. The purpose of this section is to make analysis and design of steel structure due to different types of loads. The types of loads are dead load, which is the non-dynamic, invariable forces that place continuous and permanent force on a structure. We calculated the weight of the solar panel and load of steel structure. The live load is the variable load that can change over time, such as people walking around a building or movable objects such as furniture. The seismic load is the external force applied to a building structure as a result of an earthquake-generated agitation. The wind loads, dynamic loads that are placed on the exterior of a structure by wind. The codes and standards we used are ASCE 7-10 and AISC 358-10. By following these codes, we came up with the proper design properties that helped us calculate each applied load as shown in the project design file. These properties helped narrow down the equations required by code to find inputs and outputs of each load. After coming up with certain calculations, those numbers are then used to get the desired design criteria.
My name is Ali Al-Ajmi. I will be talking about design of columns. For the columns we use column section W18 by 158, the exile service load 120 kips, and the column yield stress Fy we used 50 ksi. The unbraced column length is 10 feet. We calculated the local buckling limitation and the compression capacity.
My name is Ahmad. I'm going to be talking about the design of beam sections. So for the design of the beams, we went with the beam section W12 by 136. For the gravity distributed load, W was equal to 1.1 kips per feet. For the LB, LX, and LY, all three were equal to 6.67 feet. After calculating the FBX and going through all of the calculations required to find out if it would satisfy or not. After dividing small fbx by the fbx, it came to 0.89, which is less than 1. That means it was satisfactory.
For now, I will be talking about design of purlins. For the design of purlins, we went for W8 by 40. The gravity distributed load is 0.08 kips per feet. Axial load is 0 kips. Beam length is 24 feet. We made analysis of local buckling, determined governing moments at middle of span, allowable bending stresses, vertical flexural capacity, and compression capacity. For the bracing, we used a pipe with brace axial load of 4.39 kips. The brace design is adequate. And for the base connection, masonry strength A 1.5 KSI. Encourage rebars for number 3 bars at middle of the wall. Base plate yield stress of 36 KSI. The encouraged design is adequate.
Next, I'll be talking about the concrete structural design. The purpose of this section is to make design of concrete columns structure due to the applied loads, due to the steel structure that supports on the concrete column is subjected to this reaction of supports which is designed as fixed. The codes and standards used were ACI 318-14. The assumptions and criteria that we came up with was the base of steel column that is fixed, the concrete grade which was 4.2 KSI. The section is subjected to combined normal force and bending moments.
For the concrete columns, we have to do checks to make sure it will hold the steel structure without failure. The concrete strength is 4.2 KSI. The rebar yield stress is 60 KSI. The column's dimensions are CX 30 inch and CY 30 inch. The factored axial load is 29 K. We checked flexural and axial capacity, and we also checked shear capacity, and they were all satisfactory.
My name is Jassim Murad, and I am the project's construction engineer. I will be talking briefly about the purpose of our construction role in this project. Construction work usually consists of the methods or ways one can use in order to achieve access to the site. Here we will discuss how the construction site will be accessed in order to transport the material and equipment. For any project in the world, depending on the conditions of the site, access has to be achieved in order to make the construction work easier and less expensive. For instance, if we decide to use a crane to transport our equipment, we will have to pay extra money for the crane, operators, and street closure. One of the most advantages of our project is that it is on the top level of an existing structure. This can help narrow down the ways we can transport our materials. Since our project is to design a steel structure, it would be easier to transport such materials by trucks due to the light weight of the steel. We have decided to transport our materials to the roof level and keep the parking structure operational during the day except the construction site level. It is found that moving the materials after 12 a.m. after midnight is preferable in order to have low traffic movement. After moving the required materials for the construction, we can summarize the construction phase into 6 steps. Those steps are explained in this slide in a way that can show the building procedure without including any calculations. For the design summary, we will fix the anchor bolt at the exact location of steel columns in the concrete columns. Then we will supply concrete columns with attached base plates and fix it with anchor bolts. Third, we will join the column together by steel beams. Fourth, we will install the purlins and bracings of the structure. Fifth, we will pour self-leveling grout under the column base plate. And finally, we will fix the solar panels and necessary electrical, sanitary, and architectural works.
In regards of the costing, we have the cost of steel columns. After calculating all the cost, we broke the cost as following. Since we have 433.86 tons of steel required, the material price came out to $238,623. As far for equipment and labor, 10% of the total price. After calculating that, it would be $23,862.8. The overhead is another 10%. That's another $23,862.8. Taxes and profit was 30%, which calculates out to $71,586.9. So finally, the total price of the project would be $357,934.5.
My name is Nasser Al Faraj, and I will be discussing the sustainability part of our parking structure. Our building site is a very good site that has a large area that's easy to transport to. Our site design integrates with sustainable design to reach a successful project, and this begins with the good site selection. For our energy use, we use renewable energy like solar panels that help reduce impact to the environment and reduce the need to non-renewable resources of energy. We tend to help protect the environment by having a sustainable building that use air efficiently so that the clean energy source reduces pollution. Our sustainable building is designed to use and reuse materials in the most productive, low-cost, and clean way towards the environment. Our structure is sustainable because it has high strength, long spans, accurate detailing, uniform quality, cost-effective, and more. Our building can be sustained by following the environmental quality standards to ensure a sustainable building that maximizes daylight, and our panels allow maximum daylight due to solar panel arrangements that allow daylight to enter the parking structure that reduces energy used during the day. Our design specifies materials, steel frames, and systems, electric source solar panels that simplify and reduce maintenance requirements, toxic chemicals, and cleaners. Those are cost effective at long-term life cycles costs. The sustainable part of our project is that we have least effective contamination, cost of energy, cost of material, cost of maintenance, and cost of operation.